Recall that to solve a linear inequality, you can use the same steps as you have for solving linear equations, with these exceptions. When multiplying or dividing by a negative number, the direction of the inequality flips. So in example one, we're going to solve it. So to solve it, we would add 1 to both sides. And that would leave us with 2x is less than 10. Then we finish by dividing both sides by 2. Notice this is a positive 2 that we're dividing by. And that's going to leave us then with x is less than 5. If we needed to graph that on a number line, I'm just going to draw a number line and we'll just put 0, 1, 2, 3, 4, 5. It doesn't have to be a fancy one. 6. If x is less than 5, I'm going to draw a circle on the 5, open circle to indicate that it's not going to be equal to the 5 itself, but it's equal to everything below it. So we just shade here to the left for my answer. B, we're going to solve this. I'm going to begin by subtracting 2 from both sides, and that will leave us with a negative 3x is greater than. Notice we're keeping the direction on that inequality sign in both of these problems. The inequality sign maintained its direction. And 14 minus 2 is 12. But now I'm going to solve it by dividing by negative 3. And when I divide by a negative, I'm going to flip the direction of this inequality right here. So this is going to flip and go that direction. I will then have here x is less than negative 4. So when I graph that, my number line, I'll go this direction, negative 1, negative 2, negative 3, negative 4, negative 5. So if it's going to be less than negative 4, again, there's no equal, so it's going to be an open circle, and I'm going to shade this direction to the left. It shades the direction that the inequality is pointing, as long as your x is on the left side. C, we have 2 minus 3u is greater than 8. So let's put an equal in here. Let's make this one be equal. So let's make it be greater than or equal to 8. So we're going to solve it. And to solve it, let's see, we will subtract. You can do a couple of things. I'll subtract 2 from both sides. That will leave me, this cancels, this will leave me with negative 3. Negative 3u is greater than or equal to 8 minus 2 is what that is, and that's 6. Then I will divide both sides by negative 3. And that will result in u is greater than or equal to negative 2. Oh, I divided by a negative, right? So when I divide by a negative, it's going to flip the inequality this direction, and then 6 divided by negative 3 is negative 2. So when I graph it, 0, 1, negative 2, negative 3, I'll put the circle on negative 2. This time it's equal, so I'll shade it in. And again, now that it turned around, it's still going that left direction. Some inequalities simplify to statements that are always true, and others to statements that are never true. Example 2 is this inequality sometimes, always, are never true. Now, it's sometimes true in all of those first examples that we did. For example, 1A, it's true in the situation where the x's, the numbers are less than 5. So it's true for all the blue lined numbers there. And in B, for sometimes, it's only equal sometimes, which are the numbers that are less than -4. All right, so other times it's going to be an always or never. Let's work these problems. This is going to distribute to get rid of our parentheses. So 3x plus 3 is greater than or equal to 6 plus 3x. Let's gather our x's to the same side. So when we subtract 3x from both sides, it results in 3 is greater than or equal to 6. So I know whether that's true or false. Or is the number 3 greater than 6? No, that never happens. 3 will never be greater than 6. So this is going to be a never. So the answer really is that there is no solution. So a 0 with a slash through it. Make sure you get the slash through it. So it makes it no solution. B, let's simplify this left side over here, and I can combine 9 and a -5, and I will come up with 4 subtract x is less than -x plus 4. Gather my x's together, so plus x cancels. I get 4 is less than 4. True or false? That also is never true. 4 is equal to 4, but 4 is not less than 4. So this also has an answer of no solution. If one of our problems had resulted in a situation where you had 5 is greater than or equal to 2, we would say that this is always true. So in that situation, no matter what we substitute, we will always get a true statement. So there are an infinite number. So an infinite number of solutions in this kind of situation here. 3, your test scores are 82, 76, and 78. What's the lowest score you can make on your next test to have an average of at least 80? All right, so in order to find an average, we want to add up all of our grades. So we have an 82 on the first one, plus a 76, plus a 78. And we don't know what we're going to make on the fourth one, so we'll call that x. So x is going to be equal to our fourth test grade. Then we'll look for an average. We add everything up and divide by the number of grades, so we divide by 4. And if it has to be at least 80, then it can be greater than or equal to 80. To solve this, I'm going to multiply both sides by the 4. So we'll multiply through by our 4, and that will leave us with 82 plus 76 plus 78 plus x is greater than or equal to, and then 4 times the 380. Here, these canceled here and here, and then I get the 4 times 380 right there, and get 80 and get 320 on that right side. I need to add those numbers, and when I add them, I get 236. So now I have 236 plus x is greater than or equal to 320. Solve it. I need to subtract 236 from both sides, and that will result in x is greater than or equal to 84. So in order to score an average of 80 or better, I will need to make an 84 or better on this next test.